Okay, and we have the recording running, so if you're new to the situation, just realize you can either ask to stop the recording and we'll pause it, or just don't say anything or hide your camera if you'd rather not risk being recorded. My name is Carl Ott, current interim president of Dallas Personal Robotics Group. Today is the 29th of March, and this is our regular once-a-week Robot Builders Night virtual. We'll do the usual thing and just go around the table and talk about what's on our mind, projects we've got, questions that we normally have, just open discussion. And just a little bit of housekeeping. We do have this robotics chat Discord server that our friend Murray from New Zealand set up. So if you'd like an invitation, just put a chat in or raise your hand. We'll get a fresh invitation out. We're still waiting for volunteers. So the January annual meeting is still kind of on hold. As a positive thing, we have Jesse Brockman, if you remember, joining us from, I think, Iowa, but SparkFin ambassador. He's going to present on Oak Delight and tell us about his contest entry. So I'll show you something more about that in a moment. And I'll get the invitation out on Meetup in the next day or two. And then we have these ideas for various presentations in coming months. I've just been gathering them. And then when someone gets serious enough to claim a date, then we'll do what it takes. Okay, so then about Jesse's presentation. So we have here, he sent a few photos. So there's a contest. I guess Opencv is holding a contest, and kind of a record of how the attendance goes. So the team in this contest is called Midwest Rovers. And this is one photo that he's got of, I guess, related. And he's also got a Lego contest that he's entering in. That's what his Lego bot looks like. And it's kind of cool. The Opencv recognizes street signs and dots on the ground to navigate. So just a kind of a hint as to what he'll show to us later on. I've seen some videos, early videos, and it's kind of neat. There's a downward view of his box. Looks like it's in a travel container. So basically, he's going to be showing us how he's used Oak Delight for detecting objects and navigating. It's for this contest. I'll copy and paste that in the chat window in just a moment. And anyhow, you can read here what it's about, but that's coming up on the 9th of April. So thank goodness for people stepping up to volunteer and present. So having said that, we have one person in queue to present or talk or raise a question or something, and that's Paul. Just so that we can get a kind of a queue going, does anyone want to talk about something after Paul, a topic to put on the table?
Carl, I have just an announcement, something that I found that is very small, but I thought people might be interested in. Maybe I can go before Paul.
That sounded like Doug, but very soft. Asking if you can go before me, and for sure.
Okay, I guess I'll talk a little louder.
Okay, does anyone else, before you start, Doug, does anyone else want to jump in, get on the list after Paul? Oh, Ray. Okay, good. Okay, so here's how it'll go. Doug will get on the list before Paul, then Ray, and then it'll be kind of a free-for-all. And like I mentioned earlier, I have to step away a little bit, so if you all could just manage it, it'd be good. So Doug, what you got?
Okay, well, I don't know if everybody is on the Donkey Car newsletter, but they have just made a new software release, version 4.3.6. That's their first major release in 9 months. And they have a list of 30 features that they've added. And they've also announced a PC board that apparently eliminates the need for a servo controller. I guess it's not Polo League. Who is it? Adafruit server controller board. But so I just, if anybody will just bear with me, I'll just show their announcement and then their change list. Okay. And okay, so here is their announcement. This is their new board right here. That they call it a hat. Apparently, it includes odometry connections, the servo controls you need, and also the throttle and steering RC input. So it's kind of cool. Let's see. And I'm not sure what a new battery holder does, but and then they talk about some races. Here's a picture of a race a picture of a course that they used earlier in the year. It's a figure 8 course. You can see it's quite wide. I was a little surprised at how wide it was, but I don't know how many cars they run at the same time. It's so anyway, that's I would think that what we did in our building would be harder than this, but I might be wrong. And then this is their things that they've moved. There's a lot of stuff. I'm going to copy this. I'll copy this in the chat. And that's probably it. I'm going to stop presenting. Okay. So I just wanted to bring, if people weren't aware of that, I just thought I'd bring it up.
Cool. Thanks, Doug. And for those that don't know about it, I'll put a link into the Donkey Car open source project. But basically, it's a pretty interesting little. Here, I'll do a brief prezo for those that may not be familiar with it. Here we go. I'll share ever so briefly. And the basic concept is that what you do is you take any old RC car chassis or anything that accepts a steering and throttle servo command and a typical standard PWM as the base, and then you 3D print or get some assembly to hold a pie, and then this now replaced daughter board for a servo adapter, and you mount a camera. And in pretty short order, they have a nice set of documentation and such, but you get it assembled, and then you manually drive the car around a course, and through that you train neural net models and on how to drive the car, and then it uses the ones. When we were doing it in the DPRG club, it was pretty straightforward, pretty simple, kind of a linear predictive model, but it basically on a frame-by-frame basis predicted the most likely throttle and steering given the image that it saw, and even with that simple-minded of a neural net. It's not loading for us here, but it was able to navigate around these courses pretty well and pretty quickly too in some cases. So a couple years ago, a handful of us assembled these in the club and made adaptations and run them on our even differential wheel frames. But anyhow, from this place, you can find all kinds of documentation, and there's a Discord channel and pretty good GitHub and all kinds of good stuff out there. And like I say, several of us that have experience actually doing it. So if you're not familiar, there's the link. And with that, I think, Doug, between you and I, we've commandeered Paul's pole position. So is there anything else we should mention before we hand over to Paul?
Let him let's let him talk now.
Okay. Very good. So we have Paul and then Ray and then kind of a free for all. So like I said, I'm gonna step away. Talk to you later.
Doug, you're the man in black. Did you know you're the man in black?
Yeah, I guess I might.
Okay.
I was eating,
right.
so I didn't want to, have you guys looking down my mouth while I'm eating peanut butter sandwiches. But
That's fine. I just don't know if you knew. So I've done two things that I can show the last week, which are both quite made me quite pleased. One is I got the BNO 55 integrated with Mobots software, and so that's it, just sitting up on top of this little plate here. And so just to demonstrate that it's actually integrated with the raw software that tells it to rotate, I'm going to tell it to rotate 90 degrees and lift up. And if you pin my window to the to your screen, then you'll see it like full screen. And as you can see, the wheels are like turning quite happily and not stopping. And when I drop it down, rotates 90 degrees. So that's that. So gold star, yay!
yeah, I got you. You
I
got it.
gold
Okay.
Okay, the other thing that,
the gold star I draw on my paper is more impressive than the one that's on the web. So you get a gold.
I just like seeing David wave the gold star. The other thing I did that was, and I posted to the list, was got an SSD booting Ubuntu 20.04 on an RPi, and Doug told me a few weeks ago that it would be pretty straightforward, and it was a bit of a bum steer, Doug.
Well,
but that's okay.
The one thing it is, if you want to boot up on the SSD, there's one thing it's the SSD selection that's important. It has to be able to do a sector size of,
yeah, you said
41 something bits. Otherwise, you can't. The Raspberry Pi can only boot up on a certain size sector, and a lot of the cheap SSD cards, especially the ones that use the miniature format and not the old SATA. Otherwise, you can buy a small drive that's SATA, but you also can, I think it's called M3. There's another format, and they often don't allow you to boot on anything less than, I want to say 4K. So you can't, it won't, oh, that's right. Okay, it's coming back. All right, so for the Raspberry.
The problem, so to interrupt, Doug,
yeah.
The problems are a lot deeper than that. But anyway, is there any interest in having a look at like the hardware that like I put together to make the SSD? Okay, I'm seeing David nodding. Okay. So let me pull this out. And so let's see, we can just open it up. So this is the bowels of Mobot as it is now. And let's see, as before, we've got the RPi, which now has a cable going off to this USB hub, 4-port USB hub, powered hub, so that the disk doesn't pull power out of the RPi because it doesn't. RPis apparently don't have much juice.
Right.
Meant I had to stand off the Wi-Fi connector a little bit, and then back in the guts there, you can kind of sort of see. Well, if I pull it out on the mid plane. There we go. So on the mid plane, back of the mid plane, is the SSD with the USB to SATA connector cable coming out of it, going off to the hub that powers it, and then the hub goes off to the USB. So that all worked as expected. The key issue turned out to be that Ubuntu ROS Noetic requires Ubuntu 20.5, sorry, 20.04, and that thing you can install it using RPi Imager, but you can't, but it won't boot. So it was a quite a business to get it to boot, and yeah, I think this should hopefully, nope, that's the wrong window.
We should unpin you now.
Yeah, unpin me now. There we go.
But just one clarification: that the drive you just showed us, is it actually communicating USB to the Pi?
Yes. So it uses a StarTech SATA to USB cable over USB 3.0, and then the drive is a Samsung 870, and then there's the 4-port hub. So on Mobot's webpage, I put a list of the parts and that I used, and then a list of the procedure. So for the SD card boot, that was trivial, but the SSD boot, the key thing was finding this web page from James A. Chambers, which provided a script, and one of the main things they do is add an extra, what's it called, an extra DTO file to config.txt, and somehow that allows Ubuntu to boot. So Ubuntu was just hanging. I could boot Ubuntu 21.10, no problem, after installing it with RPi Imager, but it wouldn't boot 20.04. And so once I followed the instructions on this, and the link is there, and it goes down as you install and then run this automated script. And the automated script does some funky stuff that I don't understand. In addition to using an extra DTO, it sets some other parameters in the RPi's config.txt. And so anyway, it was like challenging, to say the least.
I know I can't tell you about the Ubuntu. All I can tell you about is Raspbian. And this is it.
Right. And
this is it. And the real key there is that you can't, at the start sector, the drive has to have either 512-bit or 1024-bit. It can't have a 4K bit.
Yeah.
And that's the main thing. I mean, it's just, there it is, it's that simple.
Yeah. And from what I read, there are also a bunch of SATA to USB cables on the market that don't fully implement the standard and therefore won't work in this application.
I've had that. I got two cables, one works and one doesn't.
Yeah. So from my reading, I found that these two devices, particularly the StarTech.com, is strongly recommended as everyone seems to find that it works. And then there are a couple of different SSDs that people find work. So anyway, it was pretty easy to make it work if all you wanted to do was run RPi off of the SSD, or Ubuntu 21.10, but the 20.04 was more challenging.
Okay. This is an OSZ drive that I've been using, and it uses a value GIST, or VAUEGIST controller cable, and that works too without any major.
Okay.
This is just an old 128 drive that I had that I'd taken out when I'd upgraded to a bigger drive on some laptop.
So Doug, are there electronics inside that connector?
Yes.
And how are they powered?
They're just on these. They just come off of the USB 3. You want the 3 for the speed, but you use the power on it. And they're what I did. Like I said, this works fine. The little one works better because it's less power than this one, but this works fine too. But what I found when I used the light with the Oak D light, that I couldn't run this with the Oak D light because it would brown out. So but it is nice. You don't have to worry about having an SSD card in it at all.
Yeah, and so the thing, a part of that procedure a part of that procedure was they had a link to to a benchmark, and so I don't know if you all can see this, but I ran the benchmark, and it came in at 322 megabytes a second disk read, 60 megabytes a second disk write, and then 4K random read writes at about 18 to 20 megabytes a second. So pretty impressive performance. And I have to say that, Doug, you said it would work much better, and it does. It feels, I mean, just subjectively kind of comparable to my laptop. Now, I'm sure it's not in actuality because it's it doesn't have as many processes, and the processes aren't as fast. But just to say that it's pretty good.
Yeah, it definitely worth trying if you happen to have the parts, or you can afford to get similar parts. I mean, with the Oak D Lite, which is where I really would like to use it, I probably won't be able to use it unless I figure out a better power solution. And the hub might be the right way to go.
Right, and that's why I did the hub, because I intend to mount my Oak D Lite on this, and I knew that it would run the SSD off of the RPi, but I knew that once I added the Oak D Lite as well, that it just wasn't going to work. So that's why I went with that powered hub.
Yeah.
On a completely different subject, one of my friends sent me a link to an interesting seminar tomorrow that's happening tomorrow at 10 Central. So I don't know if people are interested. I can post the link to it in the chat room if people are. But anyway, it seems like everyone's coming out with time of flight sensors these days, and Analog Devices is no different. They've got their own line of time of flight sensors. They seem to focus on high pixel count devices. So like this is a megapixel. So I think this is probably the 640 by 480 device. And it seems to have, from what a preliminary read of the specs, looked like it had a 6 meter max 6 meter range. And then they got a whole bunch of time of flight products here. So anyway, I thought I might go to that and
Yeah.
see what they got.
Please put the link in. That looks good.
Okay.
Any idea on pricing or?
None at all. I only found one of my friends sent me a link to this earlier on like late this evening, and I was like, oh yeah, that looks interesting. I wonder if the group might be interested in that. So yeah, I'll post the subscribe link. You do actually you do have to sign up and say, what's your position in the company? Are you a hardware engineer or a CTO or whatever? And so, there's a whole registration deal set up included with that. But if you don't mind filling in that, maybe might be interesting.
Well, if you have an analog account, you also get access to their circuit simulator. Their Spice version of Spice, which is really pretty easy to use as those things go. And
Spice is still around. Oh my God.
Oh yeah. Well, I mean, the thing is, what you find is people who do integrated circuits use Spice all the time for their circuits, but we don't make integrated circuits. Where we make is, when you're trying to make a little interface from item X to item Y, and you want to make sure all the voltages and everything respond the way you want. So our use of it is going to be simpler, but it's not real super hard to use once you figure out a few things. So anyway, I'm just saying, not only can you get into their seminars, but you can also download their version of Spice, which is really cool.
So that's all I had. I think Greg was up next.
Oh, okay. And now for something totally different again. Anyway, I think is David? Yeah, David's there. David, here's an example of the rule of three. This is a bracket that I was trying to make, and I've been using Easel, and Easel adds a couple of, like, 2 lines at the bottom end of all of their files. And I looked at it, and it's, one is a G21, I think the other is a G90. And usually those are the beginning of the file, and they say, I want metric units and absolute, positioning of tools and stuff. Anyway, so like I said, usually those at the beginning, and I saw them in there and just decided, well, I don't know why those are there. They don't really need to be. So I took them out, and it made things be very crazy. So this big rip out area here is where it ignored one of the statements by pulling the bit back up, and it just, chewed the metal all the way across here.
Nice.
This round hole is a hole for the bearing, and this holds the ring in. So here's one with the 2 screws, and those holes are threaded. So with short little screws and Loctite, that'll pretty much hold the bearing in position. So the other thing that I tried was using a 1/4 inch, basically a two flute mill, to try to get it to drill holes. Well, the tool basically shattered And instead of making a 1/4 inch hole, I don't know if you can see that, but it chewed out this hole really big. And so that was I guess that was the second mistake. So, and the other one, I thought, well, okay, I'm going to fix all the programs. Here again is where it's trying to get back to 0 without raising the bit up. So it started to make a groove with a drill bit, basically, which is not a very good milling bit. So anyway, so I guess to make these, you have to mangle the heck out of one. It's like the sacrificial one. So, but anyway, this is the one that, this is like the last version. So I've got these 2 holes drilled. I don't have them tapped yet, but the bearing sits in here, and the 2 screws hold it in position. And then there's one of 4 screws in the bottom that I was supposed to drill out, but haven't yet. I was trying to get, the drills weren't going all the way through, but I was afraid of hitting the fixturing, which I didn't want to do. So I, did a little experiment, lengthened it just enough, and I thought, okay, well, it looks like it's going to clear it. And then it plunged down. I got nervous and I hit the reset button. So it stopped, but it stopped at the bottom of where it was drilling. So it did drill through. So anyway, and these are to replace these clunkers, which weigh a lot more. So basically, this is substituting in for this. But and this is like, I don't know, I think just a few ounces. I think I said 2.7 ounces, and this is close to 30. It weighs a lot more. So, and I don't need the extra weight. It is very stout. It would probably last a lifetime, but it's just too heavy.
So Ray, what made it successful? What did you do that made it successful?
I put those statements back in the end of the program, and it worked fine.
Okay.
I have no idea why easel requires that. Like I said, I've usually stick those 2 statements in the only once and in the top of the program, so whether you're absolute or incremental, and whether it's metric or inch, but taking them out makes it ignore statements and just try to go to it looks like it if they're in there, it'll follow the G1s, but not the G0. Well, it'll follow the G0s, but not the G1s, because the G1 was what should have raised the bit up to get it out of the way of the stock. So it's been kind of interesting. That was a head scratcher. It's like, okay, I don't know why easel needed to put those in there, but if you take them out, that's what you get.
So when you were drilling, you were using a 1/4 inch drill bit, and you were actually drilling.
Yes.
Okay.
But I thought one of the
so
experiments that I
were-
thought I'd try was using an end mill as a drill, and it was a 1/4 inch end mill. And
that won't work. Not enough room. Usually you would use like an 1/8 inch mill and go around in a little circle.
oh yeah. But it chattered on the workpiece, and I think 90% of machining is actually hanging on to the stock, so it doesn't chatter, doesn't move. And I don't have a lot of things for fixturing. I'm using 1, 2, 3 blocks, bolting them down to the table, and then clamping the stock to the table with like vice grip clamps.
There's it also, if it's chattering, you might be having a feed rate problem. And there is, let me see if I can find some of the companies that sell milling bits and stuff actually have phone apps that you can download.
Oh yeah, that's like for a given material and a bit, and it'll tell you speeds and feeds and
speeds and feeds. So
are they free?
Yeah, at least they were when I downloaded it. I'm not a big user. I'm not a big user of it because I don't do that much. But
yeah,
but they did give me a good starting point.
Uh-huh.
So I'll tell you what, if I see it, I'll put it in the chat.
Okay. Anyway, that's all I had. That's something totally different.
Mm-hmm.
I have
Ray,
a question for Chris.
What's that?
I have a question for Chris.
Ah,
Chris, what is that blue and black thing on the wall next to your right shoulder?
That's one of my Wi-Fi access points. I was running out of desk space. I need a bigger desk, so I have a switch. You can't see the switch, but I started bolting stuff to the wall. I need more surface area to spread my things out. So
There's a long and venerable tradition. Well, I was suspicious because that looked like Wi-Fi antennas sticking out there.
it is.
I've got a question for everyone. All the camera guys out there. I know that David uses sonar and he can detect chain link fence. But I know the little cheapy ones that I'm using and several of us are using won't detect chain link fence with the ultrasonics. So I'm thinking about approaching it a different way and using Opencv or AI. So can I train it to detect a fence? So fence on the left, fence on the right, fence in front, basically, to help, make a determination, follow along a fence, that sort of thing. But anyone
what would
had
you be
any
looking for?
experience?
Like the chain link pattern?
Like a chain link pattern or a fence board pattern, that sort of thing, so that you can, take a bunch of pictures of a fence and train it. That's a fence on the left, or it's a fence on the right, or it's a fence in front of you. So that's what I was thinking of, trying to detect some of these hard to detect things.
Pat,
I think would be hard to detect.
you may be leading the way on this.
So I don't know. I've never done any training for AI models and that sort of thing, but it's something I've been contemplating, that, for my outdoor bot is, what can I use? Because the venue I wanted to use last year for the outdoor bot, the Robo Magellan? Robo Columbus.
Yeah.
There was chain link fence on the site, and I would eventually have to navigate along this chain link fence and be able to detect it. So it's something that I have in the back of my mind to see if it's doable.
Could a radar work for that?
A radar?
Yeah. I've never
I don't
used a
think
radar
so.
before. But...
So everything I read about the radar, the problem I find is that they're essentially almost omnidirectional, or in front or behind the robot.
Okay. Huh.
So it makes it a little bit tougher, that as you turn away from the fence, it still sees the fence. And I don't believe it doesn't know if it's behind or in front of the robot at that point.
Okay.
Well, okay, so Pat, have you, two thoughts. The first on the radar thing, have you looked at something called the I think it's a Wallabot?
Okay,
So-
Wallbot.
There's a, Lowe's has, it's kind of like a high-end stud sensor, but it comes in, if I remember, like 3 levels, and it has like millimeter wave radar sensors, an array of them. And the 3 levels are how many sensors that it has. And those things are, they're, in a way, I think they're almost meant to be hackable. So they have a healthy open source community. And they can give you like a 3D radar image. And I think Harold might be able to chime in because.
Yeah, we had a bunch of them at Hackster.
Yeah.
We had a bunch of them at Hackster, and we used them and played with them. And in fact, I gave mine away to somebody who was going to use it more than I was going to use. And not only did they were really great, because not only did they have a problem with them, the one I gave it away, they said, "Oh, that's really old." He explained how he got it, came by it, and they sent him a brand new one. And
so that's the first thing that comes to mind. And there are, is that the right name for it, Harold? Is it a Wallabot or well? Do you remember the name offhand?
I just looked it up. It's Wallabot. WALABOT.
Can somebody put a link in the chat for that?
Does seem like millimeter wavelength might just go straight through the chain link fence, though.
Yeah, so there is that. Which leads to the other thought that I had. And Pat, you were talking about camera and Opencv, and I was wondering, are you strictly thinking RGB or are you thinking like a depth sensing camera?
I've been thinking just strictly two-dimensional. RGB.
I don't see any reason why that wouldn't work. That's not the same as saying that it would. I think the reason that the higher power sonar get a reflection off, you're getting a reflection off those little bitty pieces of wire, so you're not getting very much back. But there's enough for the higher power sonar to see it, but not for the lower power sonar. However, light can see those things just fine. I don't think detection and reflection would be a problem. So I'm not really well versed in the whole AI training. There are people here in the group that know a lot more about this than I, but just at first blush, I can't see any reason why that wouldn't work.
Yeah, so optically, to spot the fence outdoor with an optical sensor other than a camera, you're dealing with a lot of UV and infrared light coming through. And that's one of my concerns, is trying to do that outdoor reliably.
Well,
I'm
that's
I'm
always
not sure AI would be reliable as well.
Yeah, I don't know that it would. Harold, I think you I don't know. You probably have done the most like independent training or learning, right? I mean, but I thought you were, you had to segregate it into what it was and what it was not as far as images go. And chain link fence being transparent, I mean, how are you going to say that, okay, this is a chain link fence where there's all kinds of stuff behind it? And
that's one of my concerns, because sometimes on these smaller systems, the training image is quite small.
Yeah, but this is where I think you need to challenge yourself about what are you using to train, and if you're even going to go the route of a neural net, then what is your input to the neural net? So remember, like in the donkey car, how I mentioned earlier in the call, it was a really simple thing. I don't think they did much pre-processing at all. They just took the raw camera image, fed it into the neural net, and let God sort it out, right? But I think there's another approach that people talk about, which is put some Opencv and do some algorithmic stuff in front of the neural net, the heuristic stuff. So, for example, I think you could craft an Opencv algorithm that would isolate patterns of small, highly reflective lines that are very different from whatever background happens to be behind the fence. So I think that
you might be able to.
Just like color extraction, you're talking about just looking at
edge extraction.
Yeah, or edge extraction.
And there's all kinds of different filters. Like there's ones that'll just bring out like things that have like enough of a contrast from the background that they and there's different ways to represent it. But at the end of the day, then you can extract from that like lines. If you know that the fence is more like a vertical and horizontal, you can have it favor vertical and horizontal. If you want to assume that it's angled, I mean, there's all kinds of things you can do. And I think once you would take that pre-filter from Opencv, then you might be able to feed that into the neural net and say, fence, not fence.
Okay.
Is the concern that you have a fence with a fire plug on the other side of it, and that the recognizer will say that's a fire plug rather than that that's a fence?
No, currently I'm just worried about hitting the fence. Not seeing it. Hey, my target's just over there, so let me go through the fence.
Nice orange cone behind the fence.
This is what the case would be if I use the grounds location I was looking to do the Robo Columbus last year. So Hey, in all competitive spirits, that's the course they've given me. Well, that's the course I will attempt to use.
Just a question for you, Pat, though, where you saw the chain link fence, was it just like a strip of fence across an otherwise like barren parking lot? Because anywhere I've ever seen a fence, there's typically some kind of transition of terrain as well. That if you were focusing on the, immediate distance on the floor in front of the robot or the ground in front of the robot, you should notice like a line or something, some obvious large transition.
Yeah, so there's going to be either a pipe or a board at the bottom of the chain link fence. There's going to be something there. But Carl gave me an idea as well. Most of the chain link fence I'd be dealing with is in a diamond pattern. And to do edge detection at essentially, a 45 degree or near 45 degree angle wouldn't be that hard to implement. Say, hey, look for edges, but only look for edges that are in those directions.
It tend to be. I think there's ways to do that.
Yeah.
Yeah.
There
The
is.
other thing you do is look
You
for
can extract horizontal lines
lines.
from an image, or vertical lines, or a combination.
Mhm.
So
And
that
the thing
gives
is
me an
that-
idea what to look at.
And the thing is that if you make some progress with that more straightforward in a way, algorithmic approach, you may not even need the neural net.
Yeah, well, that's the thing, because the neural net doesn't just look at the chain link; it looks at everything in the image.
Well, that's if you feed it the whole image. But what I'm saying is, take the image, run it through Opencv, and then feed it the isolated image that only has white lines where it thinks it sees a fence.
I think what he's saying, if I understand, Carl, is that he's going to be trying to recognize other things as well with the same neural net.
Yeah, so there would be, well, with that neural net would be chain link fence or a wooden fence. So to try to detect any type of a fence.
The classic problem everybody here's run into is, you have false positives and false negatives, right? So false negative means that you didn't sense the fence and you run into it anyway. So that's kind of the highest priority. And false positive finds yourself dodging around and avoiding diagonal shadows on the ground and things like that you don't need to avoid. And sometimes those turn out to be a bigger problem than, I see Paul nodding his head, those turn out to be a bigger problem than the false negatives. I'm sorry, false positives, false negatives.
Yeah, well, if I did it with edge line detection on edge detection in Opencv, I think I would look for more than one diamond pattern in it.
Yeah, that
But
would be.
suppose you have a bright.
If a significant
ahead,
portion
Tom.
of the field is covered by diagonal lines, it'd be much less likely to be a false.
Yes. So if I have
But
only
suppose you have a
one,
bright sunlight that's casting a shadow of the fence on the ground.
Yeah. Or
yes.
blades of grass,
But isn't your goal just to detect anything that it can't drive through, not just fences?
It's
A fallen log, piece of
there's other sensors to detect
cardboard.
a fallen log or a tree in the way or stuff like that. So it's not to detect everything, but it's just to detect, I was thinking, the hard to detect things. So I have ultrasonic sensors and I have laser distance sensors, time of flight sensors that can help detect logs in the way, that can help detect obstacles in the way.
Mhm.
But it's where those aren't good at detecting like a chain link fence.
Right. No, but you're looking at implementing a camera.
Yeah.
And you're looking at training it on something. So I would suggest training it on large transitions in your visual field, and then you could, I don't know anything about what everybody else has done, but the way I would approach it is, if I see something in front of me, then I would either probe it to see if it's something I can pass through, like a shadow or a curb or something, or it's not. If it's something I can drive through, and if I can't, plot around it. Like isn't that a kind of a straightforward approach? Might sound straightforward when you whiteboard it like that, but probably a lot of details.
That makes sense actually, because you could do that is mount a Raspberry Pi camera on a stick essentially at the same height as your robot would go, and just walk through the course, videoing the path you're going to take. and it could learn from that neural net basically.
But I
Hey,
just mean more generally, it's just kind of an extension of the line following kind of concept. If you've got a camera that's looking for a black line on a white background or a white line on a black background or whatever, where you can detect, okay, large change in, gray parking lot to green grass to fence, right? Like usually there's something like that. You'd notice something, or you'd notice it if it was a large line that somebody a tar stain or something. Then you'd say, oh, well, is there something there? Well, let me approach it slowly. Does my bumper go off? No. Okay, I can drive through this. Good. Or whatever. I mean, I don't know how you'd approach that. I wouldn't try to outthink yourself and start thinking, okay, I'm going to try to recognize chain link, but oh, snow fence tripped it up. Oh, a hedge, a pile of leaves. Like where does it end?
no,
You're gonna
exactly.
try to
So
train AI.
the one
Train it on just
I'm
the
sort of worried
transition.
about for now is the chain link fence, is because I'll have to navigate between a couple chain link fences.
In that same regimen, Pat, those smaller sonars don't really reflect very well off soft surfaces, and unfortunately, soft surfaces includes foliage.
Yeah.
Which, IR reflects real well off foliage. Nature in its grand design, green grass and green leaves reflect IR really well. Outdoors, you have problems with sunlight and so forth that can blind sensors. But being able to detect things that don't reflect sonar could cover a fairly large range of things if you get turned loose in a environment that has a lot of foliage. That those little sonars are kind of blind to that. They don't get enough reflection. You probably also notice if you played with those very much that it's hard to get a reflection off something like a soft piece of cloth, a towel, or something like that.
Yeah, so drives into the side of the bed because the bed skirt is hanging down and it didn't see it, so it'll drive in. I've had that problem before.
Mm-hmm.
Sort of it absorbs the sound and that's it.
I have that problem with my foot. It drives it into the corner of the bed.
How does your bot what does it have on the front of it for sensor? You have an IR.
I have two right now. I have two infra or ultrasonics, and I have two IRs at a 45-degree angle right now.
Both like each backing each other up.
Yeah. So the ultrasonics are more facing front facing, and the infrareds are time of flights are at a 45-degree angle.
I see. So it's not like you can cross-reference the two as to say, sonar is picking up something but IR is not, or vice versa.
Yes.
Because they're not actually scanning the same area. Is that correct?
Well, yeah. So right now I've tried to narrow my front-facing ultrasonics to essentially detect things 2 or 3 feet away in the wheel path of the robot. Whereas I'm using the side infrareds as for wall following or that sort of thing.
Pat, have you tried to see what kind of reflection you can get off a chain link fence when you're at a really, really narrow angle? In other words, you might not be able to see it here, but you might be able to see it here, where it looks more like a solid surface to the...
So, yeah, almost traveling parallel to it.
Yeah.
I'll have to try once the snow melts.
That's not a problem we've had to confront. Although I did notice back in the day when we were using those Seattle robotics, the precursor to the Pixie Cam, that when you took it outdoors, that it only worked well on gray, cloudy days. In direct sunlight, which we have a lot of in Texas, it hardly worked at all. And then it came to me that this was designed by people who live in Seattle. Gray, cloudy days are the norm. That's what outside looks like to them.
Not a good candidate for solar.
So the other one is, I'm either looking at using a Raspberry Pi camera to try to detect some of this, or to use like an Opencv camera.
I have a lot of barbed wire on, it's pretty much on 3 sides of my property. And I was thinking of the foam coated roller that would ride along the barbed wire. And, that way I could sense, because that's one of the things that I hate to do is mow along the barbed wire. So,
You're
just
looking
have
at
it.
like a contact sensor,
Yeah.
like a white cane.
Yeah, the white cane with the wheel on the blind man stick with the wheel on the end of it. So, it's just.
That's an option.
Ray, I have noticed around here that a lot of the farmers, especially, a lot of the farmers have torn down their barbed wire fences because it makes it so hard to plow and it gets tangled up in the tractors, and they just get rid of them.
I thought you were going to say the robots were getting tangled in them.
That's coming.
Got robotic cowboys to herd the cattle. Thanks, guys. Gives me some things to think about.
Yeah, the other idea that I have to contend with, my next door neighbor's bull is pulling up the barbed wire. It's a longhorn, and it's just sticks its horns underneath, and the grass is always greener on the other side with cows and bulls. And so I thought, okay, a robot with a cattle probe, just waiting for waiting for him to stick his horns under there. So I could come up,
Often electric fence is the solution to that.
Yeah.
That sounds like poking a bear.
Tell you what, if
Don't
you've
poke
ever
the
touched
bears.
one, you'll know.
Oh, that's for sure. I think the ones that I have are like 9,000 volts. It's, like a pulse just for a very short period of time. But if you happen to be touching that fence when that pulse comes along, you will know it.
Well, as they say, first you've got to get his attention.
Yep. So, yeah, I thought about that. I thought of stringing it along the bottom, but I don't know if electricity conducts through horns or not. He may just feel a slight buzzing sensation, and then he could break it.
You think he has built-in insulators?
I don't know. Does whatever it is, keratin that horns are made out of, is that conductive?
Just like fingernails, right?
But very thick and very long. I mean, this thing has horns that are probably 6 feet across. So.
Well, but it will have blood vessels and a blood supply in there, right? So it's going to conduct. See, Pat, it will conduct at some level.
Yeah.
If you get through the dielectric withstanding voltage of the horn down to the nerve levels and venous stuff, yeah.
The soft tissues underneath, yeah.
That reminds me of when I was a kid and we used to go out and stay on this ranch, and the house compound was surrounded by one of those single electric fence wires that's just about 3 feet tall. And there was this bull out in the field that always used to chase us whenever we were outside of the fence, and we were scared of it. And so one day, my brother and I plotted revenge, and we picked some grass up off of the field, and from inside the fence, we called the bull and held the handful of grass against the electric fence wire. And the old bull took a big old chomp, and he went, go! And he went like charging off down the field, bucking like a bronco.
Boy, talking about
satisfying
poking the bear.
Yeah, they're nasty. My next door neighbor, the only way he'll go into their pen is on a tractor. So, kind of give you an idea how nasty it is. So.
I was gonna say, guys, I can't talk bull all night, but because I'll get in trouble. But I get it back to robotics, maybe I'll have an excuse. I wanted to say I got some success recently. I got that Micro ROS proof of concept sketch running on my Arduino RP2040. I finally got that working. It was just, and so I I just pasted in the chat there. I did a little write up on how I did it, got it working. It's not like I invented anything new, but I just had to put together like 2 different tutorials and some known issue things and stuff. So anyway, he's got that particular board. I've done all the pasting together work for them. So
That's great. Thanks, Ross.
I got to do it publish like a publisher proof of concept. So now I'm gonna figure out what I want to publish and how to integrate that into something else. So.
And yeah, Ross, thanks for dropping by the last couple of streams, man. It's kind of fun and kind of cool. I hope you're enjoying the thing. And on a side note, am I fuzzy right now? Because I just upgraded some stuff. Am I still fuzzy?
You get a little fuzzy occasionally.
A little fuzzy.
It might be a benefit to the rest of it.
But
Harold, you go in and out of fuzz when I blow you up full screen.
Okay. Maybe there's some stuff going on. They did some work on OBS for its virtual camera, and that's where the fuzz may be coming from. All right, I'll shut up. Let Ross get back to doing whatever. Anyway.
No, that's all I've been working on now that I got that particular hurdle out of the way. I can continue on integrating it with the bot that I had job, but it wasn't hard. I don't mean to make it sound hard, but it was just so not exactly easy. Like, I don't know, there was nobody like stepping me through it, with that and holding my hand. So.
Well, Ross, all that notwithstanding, I think you've made remarkable progress here in the last few months, and starting from basically nothing to having moving robots and software development environments and all that stuff.
Yeah, I'm hoping to get some more progress on this, because I thought, it seemed to me that I should be able to easily have lower end microcontrollers more integrated with the central hub and control them just kind of like extensions of a larger robot. Like, just imagine if your laptop is the robot and it's got, outliers out there that are just kind of, collecting information and moving around. I don't know if anybody does stuff like that, but that's...
Well, in a certain, we've had discussions before about, multiple processors and the problems you run into with their interconnection versus trying to have a single host. But actually, that's all kind of water under the bridge now, because even a single host processor, you've got a IMU out there with its own processor, and you probably have a motor controller with its own processor. And if you've got a GPS, it's got its own processor. Camera probably has its own processor. So even a machine that's only got one main controller is still got, you're interconnected with a bunch of processors out there. The real question comes down as to whether that single processor should have its tasks divided up further, and that's almost a, how much salt is enough salt? That's really an individual question.
Well, on this board here, there underneath that it's ESP32 underneath that there. So that's like, apparently that's a standalone ESP32 that you can address. Apparently there's some hackers that have worked with that, but I don't know. So just to prove your point. It works differently with Platform IO and Arduino IDE, is that it works with pre-compiled libraries, I guess. So that's the whole trick, is that you got to get the libraries compiled first to work with it. So that was the first little bit of fun, and then the next bit of fun was trying to figure out why it wouldn't work.
Well, that's great.
Can't you get Platform IO to suck the libraries in?
Yeah, you can use Platform IO to get the libraries, but it doesn't compile properly without the proper settings in your INI file, and figuring out, because if you just follow the tutorial online that's published there, it's just kind of generics, it's like different boards you can put in your own options, and when you do that, then you find that there's a known issue with 2 different types of Arduino boards that it can't find certain libraries, which is what I was having. So I worked through that, but that fix didn't work properly for me. So I had to manually include those the SPI library, and then it would work. So just kind of every time it was following a tutorial, I would get to a step and like it didn't work like it did in the manual, and then I'd have to figure out why. And then it's like, oh, okay, it assumed that I had that package installed, but I didn't. And then okay, and then
Ross, you are listing to your starboard. We can really only see one ear.
all right.
So if I've had good luck with the ESP32 and libraries by just searching for them in the in the PIO window and then putting them in libdeps. But I did run. You mentioned SPI, and I did run into a problem with that where the solution ended up being that you had to include SPI.h in the main. You didn't actually need a library. It wouldn't link without doing that. But
Yeah, the solution on this was a lot more problematic, because if I did that, it would turn one error of SPI.h missing into about 500 lines of linker garbage that was all full of warnings, and then it would finally just say, "Yeah, I couldn't link it, exit code 1," or whatever whatever it was, and that was it. And it was like, okay. So then there was a custom Python script that you had to write to fix the linker, and then put that in your INI file. And then if you put SPI.h in your main, it would also blow up. But if you did it as a libdep, it would. So,
Well, did Pat bail out? I guess he did. I was gonna offer to show him some work I've done with Opencv to try to detect license plates.
Ross, I think the person in this group that, by my memory, that originally showed up with an ESP32 was Ray, and he said, "Oh, I've got this incredibly cool part here," and I assume that means that you've done a lot of development with it, Ray. Is that true?
I was using it with, the parts that I bought had LoRa transceivers on them. So I've been using them for, pretty much like remote control of units. All of even the autonomous units have that on there now. So I don't have any, Arduinos. They're all ESP32s now on all my platforms. So, and I've even used it. This was, let's see, what's his name? His last name is DRING. I'm assuming it's pronounced Dring, but he even made a CNC system based on an ESP32, and that's what this is. It's these outputs are the 3 pulse and direction, 6 altogether for X, Y, and Z, and it's got an SD card that I can put on it and transfer files from my laptop over to it. And you can actually do things wirelessly to it, which is great. So, I can transfer files to it wirelessly through just through Wi-Fi.
Oh, you're using one also as your microcontroller, right?
Correct.
Yeah. No, this isn't actually an ESP32 though. It's an Arduino board, but the Wi-Fi Nina module, they said, apparently is built with an ESP32 in it. So I was just saying to your point that it's an Arduino board with an RP240 or 2040 chip on it.
Processor,
but then the Wi-Fi module apparently has an ESP32 processor inside it.
So there's 2 processors on
that I read. I don't know if that's true or not.
There's 2 processors on that little tiny board?
Yeah, apparently. I can't see them, but that's the Arduino Nano RP2040 Connect. So
it's in there somewhere.
Ray, I wanted to ask you earlier, but whenever you were talking about doing your milling, I didn't get to see very much of what your project was. It looked like you built your own CNC. Did you use a drill press?
Yeah. My father-in-law died, and he had like, I think 5 drill presses, and I couldn't give the things away. We had a garage sale, and I was trying to sell them for $50, and no one, oh yeah, it's too much. It's like, go out and try to buy a new drill press. They are not cheap. $400 or $500 for the size that these were.
Mm-hmm.
So I drug them all home and had an XY table and put that on the platform, and I was actually using that to turn wooden bowls, and I haven't turned anything wooden in a long time. So I decided, okay, I'm gonna take this off and plop it up on top of the platform, and it seems to be working pretty good. It's not like it's got ball screws on it or anything like that. So they're just plain lead screws. They don't even have any anti-backlash on them. So there's about like 10 thousandths of play in each axis right now. I'm assuming that's going to get worse as the thing gets more and more used, because it's just going to wear out.
Well, can't you replace those with Acme threads or something?
I probably could, yeah. So, and the new nuts for each thing, but.
And so the bearing holders that you're replacing, what is that part of?
Oh, that's for another robot platform. I wanted to do it 4-wheel drive. I've got the wheels, the axles, the base part of it, but the pillow blocks that I bought weighed quite a bit, and I'm trying to make this thing as efficient as I can. So reducing weight is kind of key. I think the heavier platform doesn't necessarily win contests when it's down to a few seconds. Maybe a little bit lighter weight, less energy to push the thing along. And I have an older Bridgeport, but I don't know. I haven't played with it that much. It has its own set of G codes and stuff like that, but it's getting dated. It can only store 8K bytes of code. That's the total amount of code. So, and a lot of the programs you get from CAD are much longer than that.
Just like the Mercury space capsules.
That's right.
Full 8K of RAM.
That's all they had at the time, So, but I've always been interested in it and never really got to explore it. And, people have done, controllers with, the 328Ps. They've done it with ESP32s. There's several ST microelectronics processors that they've based them on, the Blue Pill, the ST, the 32F 407, I think, or 405, that series of processors. But so it's probably due for an upgrade. But the cheapest upgrade I could find is from Centroid CNC. It's about $3,000. So anyway, yeah, you could use one of those as a CNC controller nowadays. So, but yeah, so that's kind of the whole goal, to make a 4-wheel drive platform. Like I said, I had all the parts. I had these larger plastic wheels that I got from Surplus Center. They got a fair amount of tread on them. It's fairly deep, so I think they'll work. They're about 2 inches wide, or maybe 2 1/4. I forget which these were, but Anyway, it's all sitting here in a box waiting for brackets.
So Ray, this is a platform and not a mower, right?
Yeah, it's one I wanted to make for the outdoor contest with.
Okay, I got you. That sounds
Robo
great.
Magellan.
Sounds cool. Okay, I'd like to see it. Yeah.
Yep.
Oh, that's Dave's new
Ray, you
toy.
need one of these.
Yeah, they're kind of in limited supply though, aren't they?
You might need this one.
Is that the one that you pulled all the parts out to make another one that actually works, or what?
Well, let's see. I don't know if you can see over my shoulder here. Can you see the array back here?
Oh yeah, yeah.
Way more sonars than would ever be useful for anything. But I'm beginning to get a little discouraged with this platform just because it's so heavy. And just working on something, I know that doesn't mean anything to you, Ray, but just working on something that weighs that much is just kind of a pain.
Yeah.
And I don't have any batteries in it yet. It's supposed to take not one, not two, but three of those big, lead acid like you have in your UPS style batteries.
Oh wow, yeah.
And then in the instructions, they complain about how it has a hard time rotating in place. Well, duh.
Yeah. It's because it's crushing the ground it sits on, right?
One word, David, lipo.
Really? Well, what I'm thinking about doing is, the motors and the drivetrain and all that are really wonderful and quite expensive when it was new. And just rip out everything else and start from there. Start that it's just a bare mechanical platform. These arrays, you all remember what these look like. That's the front or back. And you notice that it has 8 and the 2 of them point sideways. In my experience, I've found that direct sideways sensors are not really that useful. I think I described this once before. You can't really use them for wall following or anything like that. Because if you think about it, if you're looking straight out 90 degrees and you're looking at a wall and you are parallel to the wall, you just assume you start parallel to the wall. Then if you rotate away from the wall, that distance gets longer. And if you rotate toward the wall, that distance gets longer. So you can't use that distance to tell you whether or not to help find parallel to the wall. Instead, do like what Pat was doing. If you have a sensor that's pointed 45 degrees forward, then if you rotate toward the wall, it gets shorter. And if you rotate up to 45 degrees, and if you rotate away from the wall, it gets longer. But just looking straight out, I have not, unless maybe you're trying to do mapping or something. So if I do use these, I'm only going to use 6 of them, not 8 of them. And of course, the more you use, because depending on what you think the range is, speed of sound in air is about a foot per millisecond. So if you're going to look for things 16 feet away, you need to wait at least 32 milliseconds for that signal to come back. And you don't want it to disturb the reading you get from the next one. So that means that you really have to wait 32 milliseconds between firings. That might not be the case for shooting them out sideways, but definitely for shooting them forward. So the more you add, the slower and slower your update time gets. And on the big robot, I only have 4 of them, and I have actually not found that to be insufficient. I've always wanted, because I only have about a 60-degree coverage, I've always wanted to have 90 degrees, which 6 would give me. But what I'm going to do, or what I'm working on, is just to write up a little dummy driver for this thing and test it. I have some other, I think I mentioned this before, I have some other questions about, well, let me show you. I don't have it unboxed, but here's the sonar controller. And the cables that go to the sensor itself already have connectors on the end of them. And the reason for that is because they are part of the tuned circuit. if you cut those wires and put a plug in them, for example, you detune the response. I can attest to this. So what they've done here is they've built one driver with a multiplexer. And if you look, you can see that each one of the cables that goes to the sensors is a different length. So there's no way those can be tuned, which suggests to me that they have probably settled on a very shortened, you can get, in ideal situations, you can get about a reflection from about 32 feet. The 25 feet is probably more reasonable. But if they have limited these to say you can only see 16 feet, then maybe it doesn't matter that they've detuned. But I'm a little suspicious of this, so I just want to put that out on the bench and play with it and see how it works and measure them. And my suspicion is that each one of them, because each one has a different length cable, will have a slightly different response. And I wonder if they knew that when they designed it.
Are those the same size as the sensors that you have on your other platform, Dave?
I'm sorry, say again, Ray?
Are those the same size as the ones that you have on your other platforms?
Yeah.
Okay.
The only difference is that the other ones have one of these per unit.
Yeah.
Whereas this thing's got just the one controller for all 8.
Mm-hmm.
But as I say, I'm suspicious of that controller.
So David, whenever when you talk about your angle that you have the sensors pointed on and your angle of coverage, I guess, are you talking about not the center of like say if a sensor was pointed say 15 or 20 degrees, that would be the center, but that sensor also has a an arc that would reach across to a certain degree from the robot, even further than the center point on the sensor, right?
Oh, I think that's more complicated than what I'm saying. Let me grab a robot here. Oh, I can't. It's not here. These little sonar have a beam spread of about 15 degrees. There's side lobes and so forth, but you can basically assume they have so if you've got 2 of them mounted in the center and they're pointed off from each other 7.5 degrees, then you've got basically 30 degrees of coverage. Yep. Each pointed out 7.5 degrees. Then you got about 30 degrees of coverage. And when I added 2 more to that, that gave me 60 degrees of coverage. So what I was saying was that for a sensor that's looking straight, that's normal to the robot, that's looking straight sideways from the robot, I found that that's not that valuable information unless you were using it to do mapping or something like that. But in terms of using that in order to get parallel to a wall, it doesn't help you. It'll give you an accurate reading once you are parallel to the wall, but it doesn't help you get parallel to the wall. Or I guess you could sweep back and forth and look for a minima or something like that. But that, that's getting more complicated instead of simpler. Was that your question?
Yeah, I guess it clarified or evaporated the question a little bit for me. The thing I was finding with with my design, and I'm not following any design, I'm just kind of tinkering around and seeing what somebody else does and thinking, hey, that looks cool, I'll try that for a bit, which is kind of fun, I guess, in that way, rather than anyway. I'm finding that I put a sonar on the front, and then I put a digital IR underneath it, kind of as a backup to the sonar for those situations where, it couldn't see a slipper, for example, on the floor, but the IR could, but you know what I mean? Things like that. And that's just kind of like, if anything gets within 20 centimeters and the sonar is not picking it up, it'll still stop it, kind of like a virtual bumper. And then I found that the corner, like the wheels being out on the side, the sonar facing straight off would, the wheels would catch, like it wouldn't clear it. The sonar is in the front of the robot in the very center, and it would come up to say an edge on something, and then it would drive up, then bind on it and hit it, right? Because I don't have a bumper on the thing yet, and so I thought, okay, I'd like to offset the sonar a bit so it would kind of detect a wider opening. But Lego being the square medium that it is, you know, it was kind of like, okay, I can have other sensors, but they're going to be 90 degrees to it. So I have sensors on the side, which, you know, I haven't really fully planned about how they're going to integrate it, but I kind of thought that it would be useful for at least object avoidance, like knowing that if you're going along not parallel to a wall, the wall is getting closer. It's getting, you know, like you might have a full field of vision straight ahead of you, but you're gradually getting closer and closer and closer to something that's going to snag you. And the side sensor doesn't, I don't know, it would help with that, but it would kind of only keep you in a little like a pocket of operation or whatever they call that. There's a technical term for robot envelope, the envelope of operation or whatever. So you could kind of have it, never let yourself get, you know, within so much distance of any particular thing. That's kind of the way I'm trying to use them.
And that's kind of a trade-off because at least in my experience, you know, it's good to be able to see far out ahead of you, but you really don't want to look far to the sides. But you don't really want to look much wider than the robot is, or you can't go through narrow openings.
Right. Yeah. No, I only have IR on the back, or sorry, IR on either side for 30 centimeters.
So here's a Lego robot, and it has no sonar. It's got forward-looking IR, but you can see maybe, see that sharp sensor there on the sides. And how can I show this? Maybe from the top. Okay. You see those sharp sensors are pointed off 45 degrees from the center line. They're also angled down very slightly, since those are like a laser, right? So you only get a single point of detection, which can miss things. But if you angle it down slightly, then some part of it is going to sweep an obstacle as you get closer to it. Whereas if it's just level to the floor, you can only see things at that height, which is a problem. But if I could draw here, what I would draw is a field of view for all the sensors together that would be basically lobes that stick out front and just go a little wider than the robot on the sides. You don't want to look too far out, as I say, or you can't go through any kind of narrow opening. You know, it'll turn around and go away from that. And that's pretty much just, sort of playing with it. Now, I do all this with subsumption, so those sonars are arranged in a hierarchy that basically is how far away they are from the robot. The closer the detection is to the robot, the higher the priority. So in the case you described where you get up close to something and the sonar doesn't see something but the IR does, the IR has higher priority than the sonar does. Sonar has other failure modes. It can get multipath reflections and so forth. If you get in underneath a nice metal desk, the sonar just can't figure out what's going on. Everywhere it looks, there's multiple reflections coming back. But the IR has no problem in a situation like that. So in general, if the IR sees it, whether the sonar sees it or not, the IR wins. What makes that work is the IR doesn't see most things because they're too far away. The IR can only see maybe out a foot or something like that on a little robot like this. So that's a Lego robot. Look, see the Lego parts?
When you say the IR sensors, are those just sort of it sees something and lets you know?
Yeah, they're just the forward-looking ones on this are just proximity sensors. The side-looking ones actually return distance. And so basically, depending on what their function is, when it's navigating it doesn't look any further out than about 4 inches, like that. When it's wall following, it looks out further. So the software basically decides what's a detection and what isn't. So, and I know Chris was complaining about his robot not being robust enough to do accurate odometry. And I was going to pull this one out to demonstrate that you can do accurate odometry with fairly sloppy hardware if you have some to work with. I think I think if I remember, your concern was that your wheels might actually be shifting their position slightly as you turn.
Yeah, a little bit of a wobble. Yeah, a little bit of wobble, a little bit of gear slop. So whenever I change direction, I think I lose, it swallows up encoder ticks because of the gear slop, the slack, something like that. Now, I don't know how big of a factor that is in the overall, but it's just a theory.
Fix it in software.
Speaking of fixing things in software and odometry, I was playing around with the software that I wrote for the encoders on these motors, and I had followed an online tutorial and it had it working, and I was not, I didn't know what to expect from the resolution from these little hobby motors. The gear ratio, according to the Word document turned PDF spec sheet that I got from China, that has the specs on this motor, says the 1:48 gear ratio, or 1:48 gear ratio. And I was checking it out, and I realized that the tutorial that I followed to count the encoder ticks, it had a couple of different, I don't know, just different way of doing things. And I looked at a couple other ones, and I realized that I was able to get 4 times the resolution on my encoders by watching for changes versus rises. And which the original tutorial was just like, oh, when this one rises, check if the other one's rising or not, and then you're good, right? But then I was like, oh, I watch each encoder, I can get 4 ticks. And then so it's made a big difference in the accuracy of the thing. It was so but it never occurred to me that I just thought I was like, okay, low encoders on low number of ticks on the motors in the hardware.
Ross, I think a lot of us do that, in the sense that most of the off-the-shelf software that's set up to read quadrature encoders does what you described. It looks for a rising edge on the A channel, and then it reads the B channel. And if you invert that logic, you can look for also a falling edge on the A channel, and then read the inverse of the B channel. And then you can also look for a rising edge on the B channel and read the A channel, and look for a falling edge on the B channel. So so you can get 4 times.
That's exactly what I implemented. Yeah. And so it just gave me 4 times the number of ticks to count.
Yeah, and it turns out that if you take the exclusive OR of the 2 values, it'll tell you the direction.
Yeah, it's actually fairly trivial. Once Dave pointed it out to us.
I just have 4. I probably did it the redneck way, but I just have 4 different functions, and then I just figured, like, I can't remember what you call them. I call them callback functions, but that's not the right term for them. But the interrupt triggers, there's a term for that.
Yeah, they're callback functions.
Those are callbacks.
Yeah, it's not the term. It's not the term that was.
Interrupt service routine.
Sorry.
Interrupt service routine, I think.
Yeah. There's an aspect for it.
You take the exclusive OR of the 2 pins, it will tell you which direction it's going.
Mm-hmm.
In other words, it's a very trivial function. It's not as complicated as everybody tries to make it.
No, it's not. It's just whether you're adding or subtracting based on.
Right. It's whether you're increment or decrement based on the value of the exclusive OR of the 2 pins.
Right. So that was a nice little thing that I learned just by accident. I didn't go looking for it, but it just kind of occurred to me, and I'm sure it's something pretty standard.
Well, there's also another way to do that I think Pat and Paul have both pursued. if you don't have enough ticks, which is to actually measure the time between ticks, rather than ticks per time, you return time per tick, and I think Paul's got that working pretty well.
How many ticks like per wheel revolution does do people typically want to do decent odometry? What's kind of more is better, obviously, but you could always just, multiply whatever your number you get by 8 and pretend like you got more numbers. So, you want real numbers to go with. But what's a decent output for a normal?
I don't think that it's ticks per revolution so much as it is ticks per sample period. So if you have a control loop that a lot of people do that runs at 20 hertz, what you'd like to know is at full speed, how many ticks do you get in 50 milliseconds? And a handy definition of slow speed is 1/10 of full speed, and you'd like to be able to drive it. So let's say you got 50 ticks per 50 milliseconds at full speed, then you'd say slow speed is 5 ticks. And 5 ticks is not really enough to do a good PID, because the difference between 5 and 6 and 5 and 4 is huge. And as you say, the more the better. And I think everybody has kind of, see how much you can get off your hardware, and then what can you do with that?
Right. Yeah. I just wondered what like on the bots that like Chris, for example, what are you getting for encoders for?
I'm doing 100 hertz loop, overkill, I'm sure, but I'm doing 100 hertz loop, and at full speed I'm getting 50 ticks per 10 milliseconds, right? In other words, 5,000 ticks per second, which roughly equates to 1 meter per second, rough numbers, on my small platform, which is about top speed at full battery, right? So 50 ticks at every 10 milliseconds at full speed, and so 1/10 of that is just 5 ticks, and it is I don't get as many ticks as I'd like, right? So I would like to have more. So as I go really slow, it's bouncing around there between 4 ticks, 5 ticks, 6 ticks, like Dave said, and it's barely enough.
So say you just have your bot, just the motor off your bot and the sketch watch and the encoder, and you grab the wheel, you mark it, and you do 1 full revolution on that wheel, like you twist it with the motor, the gears and everything are turned, assuming that that's how your motors are set up. How many ticks would that one?
I'd have to look that up, to be honest. Now it's
ballpark.
I have to look it up.
Ross, a more useful metric for that is ticks per inch rather than ticks per revolution.
Yeah.
So you set your robot down on the floor, you can just drive it manually and drive it 20 feet and count the total number of ticks, and then divide that by inches or meters or whatever you want. So you turn that when you start doing the math to do odometry and PID and so forth, that's a more useful number. It's ticks per inch. On my
that will be. No, I understand that. I'm just trying to get a feeling for how crappy or how average my motors are as far as ticks, like the number of counts the motors have built into them, because they're like $7.99, and I don't know if they're going to be useful or or if I need something with that, because I see the tutorial that I watched this girl.
Well, how many do you get? Let me put it this.
I think I'm getting. I'll have to look now, but I think I was getting.
I think you want to be in the hundreds.
Oh yeah, no, yeah, that's what I was getting at first. The first one was 132, and now I'm getting like almost 4 times that, but not exactly 4 times.
That surely sounds like plenty.
Oh yeah, it sounds like
if you run into that problem. My best performing robot is that little RCAT, and it has 500 count per revolution optical encoders, and I read the rising
Yeah,
and
but
falling.
that's for the motor, right? Then there's gear reduction, so you
Well,
get
that's
a
what I
lot
was saying.
more.
So
Yeah, so the
so
motor
I
goes
get about
around.
3,000 ticks per inch.
Yeah, I guess like that's all going to depend on your wheels and everything like that. I understand with the odometer. I just mean like if you took the motor shaft and clamped onto it with a pair of vice grips and twisted it around one full revolution of the motor shaft, am I counting a decent number of kicks on that or not? And it seems like I am. So
Yeah, so I'm
100
getting like a little more than
With-
100 per inch.
When you said you're getting 130 or so ticks, was that per motor revolution or per wheel revolution?
Well, the gears are in the motor, so the motor is, I grab onto the shaft where the wheel comes out, so after the gears. So
So
I
it's
do
per
That's
wheel,
per wheel revolution.
what you're
Wheel.
saying.
per wheel revolution, 132.
So that's not much.
No, it's not much that if I wasn't counting all 4 ticks, I could have counted. So then now I am counting all 4 of them, and I don't know the exact number because it's not an exact multiple. It's,
But even 400 per wheel revolution, how big are your wheels?
60 millimeters, I think.
2 inches?
Let me see the. No, I don't.
That's a 6-inch circumference.
Second, I got it written down.
400 ticks. About 75 ticks per inch. You're muted, David.
It's okay. I'm just being a smart ass anyway.
Yeah. The diameter is 60.4 millimeters. Circumference, I could think it's like rounded up to 190 if you wanted to, centimeters. So
I got these really good encoders from Dave. Thank you for those. I think one of them was like 1,000 ticks per revolution. I know that because I have to, well, I can sync it with the
Breaking up real bad.
whatever they call themselves.
Ray, we can't quite hear you.
Oh, yeah, my connection's kind of fading in and out. Anyway, I get 6,500 ticks at max speed, in 50 milliseconds for one platform, and the other platform, it's almost a factor of 10 less. It's 640 ticks at max speed in 50 milliseconds. So, but that I think is really pretty high. Could you guys hear me?
Yes. Ross, I do run that same little test though when I'm wanting to be sure that the encoders are not dropping any ticks. Just grab the wheel, I put a mark on it, I grab the wheel and turn it 1 revolution and then turn it back the other way and be sure it goes back to 0.
Yeah.
And that it's the same on both wheels. And for that little robot, that 1 revolution is about 5,000 ticks.
wow, okay. That's quite a number then. That's quite high.
More is better.
Well, of course, yeah.
On the other hand, that little Lego robot has probably a couple orders of magnitude fewer ticks than that, and I got it to work real well. So I think what you do is you get the most ticks you can, and then just proceed from that. And if the robot doesn't perform really well in a certain circumstance, you can say, well, that's what this robot does. That's the behavior of this robot.
I was going to show a couple of things I pulled out of some hardware. I pulled apart some multifunction printers just that were going in the junk, and I found that they have these kind of things in them. I don't know if you can see that, but this is a
optical encoders, yeah.
with an optical encoder wheel on the back, and I'd say that's I don't think it's optical. I think it's magnetic, but it might be a Hall encoder, maybe. I'll see if I can.
If it's got slits in it, it's probably optical.
It's got.
Yeah, it's like
it's plastic with black lines, and there's so many of them.
Yep.
Like, I don't know, there'd have to be thousands of them. Hard to say. Tiny. Can't see them. So I don't know if that, yeah, how to use something like that, but interesting little gears, like geared motor. So fun experimenting. There's some big, nice, good motors out of them, but but the encoders that come with that they use for these are like located off the motor. They're on a shaft the motor was driving. They're not really useful, but
Ross, what's your intended max and minimum speed for this robot?
max and minimum speed. I don't have an intended speed, whatever it'll do, I suppose.
Well, I mean, do you know how many revolutions per second the motor does when you got it on full voltage?
Yeah, I think I do. I tested that.
Ross, does it look like that?
Yeah.
Yeah, that's an optical encoder.
That's optical, isn't it?
This one is 500 counts per revolution, and I get 2,000 by counting rising and falling.
And that came with the motor. That's not an add-on or something.
No, and these are surplus tanners. That is to say, way more than I would ever pay for them new. Another just add into that is if you're going to use optical encoders, they have to be shielded from the light, which magnetic and others don't care about. But you know it'll screw them up if this ambient light strikes that. Especially you can see that's kind of a shiny wheel.
Yeah.
In this case, that one's not plastic; it's glass. It's a little glass wheel. But basically, it looked a whole lot like the same sensor you have and everything.
That's a different one, but that doesn't have the sensor with it. I just grabbed the motor and the bracket and the gears. And I just wondered if I could put the sensor on it and then use it. Probably.
Well,
Yeah,
the sensor,
Paul should glue that one to the motor shafts of his motors.
hey Ross, the black box that's on the wheel is your sensor.
Yep.
And so you got your sensor too.
Yeah, there's lots of them in the printers. There's all kinds of them.
Yep.
You end up, So this one's unique because it's one of the only ones that's actually got the whole thing together. It's got the worm gear, the encoder on the back. It actually comes out the motor rather than being something external to the motor.
Mm-hmm. So the reason I asked about how fast your wheels spin is if you take 400 ticks per wheel revolution with a 6 centimeter wheel diameter, that's about an 18 centimeter wheel circumference. That works out to you get about 20 ticks per centimeter. So if your speed, so that's where you got to factor then into your control loop rate. So if your maximum speed was going to be 5 centimeters a second, for example, then you would expect to see 100 ticks per second. And so then if you were going to run a 20 hertz control loop, you would be looking at 5 ticks per loop, which is, that's about where I'm at on my robot. And it's at kind of below what is really controllable using tick counts per loop, which is why I went to the time per tick approach.
I see. I know there's two methods that they do that, and one requires some low pass filtering and some other strange stuff. I guess that you're using ROS to take care of all that. Is that no?
So that's where the maximum speed, or the speed that you intend to run the motors at, is crucial for designing your control loop.
Mm-hmm.
So you need to know that. You know, you can't design your control loop, or you can't design your odometry sensing without that information.
Mm-hmm. Yeah, that makes sense. Yeah, because I see that's how whenever they're setting up, people are setting up PID and everything like that, they do that, drive it on a 1 meter, and then because they want to be able to measure that for their control loop, right? So.
Well, that just to second what Paul said, those are really the two values that you need to do to design the rest of the software. You need to know ticks per inch, and you need to know ticks per loop, whatever your control loop rate is. Now, one thing you can do if you don't have enough ticks is to slow down your control loop rate. My first couple of robots ran at 10 hertz. The reason I chose that was because I read somewhere that the space shuttle control loop rate was 10 hertz, and I thought, okay, good enough for them. So the slower your control loop rate, the longer time you have to accumulate ticks. So
that's only in the control loop of the sampling of the encoder, right? You wouldn't have to necessarily slow down everything else.
Well, the PID loop has to run the same speed as the sample rate.
You can't run a control loop faster than the data is coming in, but it
doesn't do anything. As a matter of fact, it can do weird things, because what it says is, I sent a control and it didn't change, so I better double that or triple it. I'm not sending enough control. So it's the same thing. If Chris wanted more ticks, he could drop his 100 hertz rate to 50 hertz and automatically doubles the rate. So that's how it is. Those two numbers basically factor into to how the control loop and later in how the odometry does its calculations.
But a simple rule of thumb, though, is there in that if you have a less frequent sample rate, if you slow down the sample rate, you're going to slow down the response to the loop, and you're going to add lag to your ability to respond to transients.
That's why, in some sense, I'm envious of Chris's 100 hertz control loop.
Or he can do whatever he wants.
My suspicion is that makes the control much smoother.
Yeah. And faster, and less laggy, snappy. If I remember reading, do you remember those that little company founded by some guy out of CMU some years back? They did the Anki cars, the little race cars that would they were not that much bigger than Matchbox cars, but they were like AI enabled, and you put them on this final course around you could battle each other and have fake lasers and stuff. Those things, I mean, they moved really quickly, but they also had, I think, 500 hertz sample rates. If I remember reading right, they would sample the sensors and the motors at 500 hertz. But, like little insects, they're so small, right? They needed it.
Well, also, none of us are really dealing with high velocities. Obviously, if you're going 60 miles an hour, a 20 hertz control loop is probably not going to cut it. What is it, 88 feet per second? So you're going to be doing a couple of car lengths between samples. But we all creep around, a fast robot is a 2 meter per second robot.
So when you guys are talking about your control loop, you're not talking about the loop for the whole bot, or you guys keep everything running on the same speed that way, or?
That's the way I'm using the term.
Okay.
I think there are different approaches, though, Ross. Because like some people might have an outer loop that's, well, I don't know. They might have an outer loop that's relatively fast, but then some sensors that only get sampled every second or third or fourth turn of that outer loop.
Yeah, that's what I'm wondering. Like, are you guys like? I guess you're sampling like your PID control runs as quickly as the next slowest data source, right? Like,
Not exactly. I think the PID control loop that's controlling the motor needs to be tied to the sample rate that you're getting back from the motor. But for
Right.
example, I was talking about those sonars taking 32 milliseconds a piece, and so if you've got an array of 4 of them, that's 125. It's an eighth of a second to get a new update. So at a 20 hertz sample rate, you're going to have gone around that loop several times, being returned the old data before you get an update. So there are other things like that. The IR sensors take a while to recover, so they have a lower data rate. But basically, when I use the term control rate, I'm talking about the PID control loop, which has to run at the same rate that the loop sample rate is. But everything else kind of runs its own rate, and
that makes a lot of sense for one of the issues I was having to what you said is that my samples and my PID were not running the same rate. My samples were slower than my PID.
no, those have to be locked together. Along the same lines, if you think about what you're doing, it doesn't help to send controls to the physical plant faster than it can respond. So part of that has to do with the weight and the inertia and so forth of the robot itself. There needs to be some coexistence between how often you're reading what the robot is doing and how often you're telling it to do something versus how fast can it really change.
I thought that was kind of something that you would adjust in the game. I didn't realize that I needed to adjust it
In the loop rate.
Have the timing of the functions the same or as close to the same as possible.
Well, but it's all relative, right? I mean, think about those spacecraft on orbit, right? Keeping a satellite on orbit, they got 20 years of fuel, and to keep it on orbit, I mean, they'll have these little jets that it's just a tiny little puff of gas every so often, just a tiny puff of gas. The thing weighs a ton, or however much it weighs. How much inertia is that? But it's just a tiny puff of gas, so it's all relative, right? Because the loop rate it just depends on like you say, David, the plant and what your response is, what you're trying to accomplish. But to my way of thinking, the easiest way to keep your brain straight and to keep from getting mixed up is you sample the motors and the encoders or whatever the sensors are, to sample them at a regular period, as fast as you can reasonably sample them, and then you take care of the rest in software. Just tune the filters and whatever.
Yeah, I kind of wondered about that because again, I'm just trying to throw the concepts together here. Like, artificially slowing down, like, if you have a board, for example, that can run like loop around at however many times a second you want to say it, and you got to do your PID sampling or your encoders or whatever data that you're trying to monitor, your input to that is slower. Like it seems that there should be a way that you could factor in that your data is slower, like, you know what I mean, without actually running the loop slow. You know what I mean? Like,
well, the loop will handle that, right? So this is what I'm saying. So let's say you got a nice healthy CPU with all kinds of resources. Let's say it can sample 100, 1,000 times a second, run all your code 1,000 times a second, twiddle its thumbs for like eons in between each sample period. So you're not at all resource or CPU constrained. So you just run at 1,000 hertz.
Yeah.
But let's say you got these ultrasonic sonars and long distances, and they only get new values every like 1/10 of a second.
Yeah.
Well, the point is that who cares? The loop is only getting new data every 1/10 of a second, and it responds with whatever curve you program into it. So the point I'm trying to make is that you can have, I mean, if you, it doesn't hurt to have too many samples, but you start to really struggle if you don't have enough samples. So what I'm saying is just, if you got the resource, run the stuff as fast as you can, and then let the data come in at whatever rate it wants. And then whenever you tune your algorithm, whatever combination of low pass or high pass or band pass, whatever, then you can take care of that stuff in software or just in the tuning in a loop.
I think, Carl, that would work if what you're doing is reading, as you say, a slow sensor, but you're updating the plant at a higher rate than that. But if what you're reading is the plant itself changing, which is what you're getting back from the encoders, then I think that has to be synchronized with the rate at which you're controlling it.
I'm not quite sure I follow.
That is to say, if you're reading the encoders every 20 milliseconds or every 50 milliseconds,
okay,
so that you get a new update of what the plant is doing, physically doing,
yeah,
then you can read that, compare it against your set point, whatever velocity or position or whatever, and send that correction to the robot at that same rate. Now, if you're reading some other sensor, sonar, whatever, you're not actually controlling that sensor when you send commands to the motors. You're controlling the motors.
Right.
So those can be at different rates.
Right.
But the commands you're sending to the motors need to be synchronized with the rate at which you're reading the motors, reading the encoders. That is, the plant needs to give you a new update each time you want to give it a new update.
Yes, yeah, so you're saying that if your error is going to be based on the measurement of the encoders, then the command then you measure the encoders, you calculate the error, and you output to the motors in the same sample. Yeah, I agree with that. Keep it synchronous.
Okay.
Where it doesn't necessarily have to be synchronous with other sensors that you're not actually directly controlling.
I guess I kind of thought that somehow the gain would tweak how quickly it responded. So it would kind of realize that it was slow to respond and you could tune it to be like, oh, for a slow response control, for example, versus a fast control. But maybe I'm confusing the concept.
Well, no, I think what you said is true, but that's different. I think from what David and I are saying in that you'll keep your system more manageable if you have the thing you close the loop around. So the error terms, the set point in the feedback, if you have that measurement synchronous with driving the motors, otherwise you have that stuff out of sync, and then what happens? Then you've introduced some kind of crazy lag in the measurement or the command, and then that's going to just screw up the response somehow.
So, for example, just to go back to the point I made previously, if your update of the plant's state is slower than the control that you're sending to the plant, then what's going to happen is you're going to read the state, calculate the error, send it a new control, but it's not going to change because your sampling rate is slower than your control rate. So the next time you sample it, you're going to get back the same. I shouldn't say the next time you sample it. The next time around the control loop, you're going to have the same value from the plant. It hasn't changed because it's not sampling as fast as you're sending it commands.
Yeah, that makes sense, totally.
In that case, so the controller says, well, I'm going too slow. I'm going to increase the voltage. I go back and read it. Did it increase? No, it didn't. It's not because there was some torque or something requirement. It's because we haven't sampled it again. So you're going to say, oh my goodness, it hasn't sped up. Crank that voltage up even more, and you'll do that 3 or 4 times. And then finally you'll get the update. Oh, now the voltage is way too high. So
it'll oscillate.
Yeah. So
or can oscillate. Yeah.
And just do weird things, do weird
Yeah, that's exactly what I had.
Non-linear things. Maybe that's the word that needs to come in here, that it produces a non-linear response.
Yeah, and actually,
Unpredictable.
if you think about it, if you say you have a slow sensor, it only gets updated every 5 times you check your encoders. Still, your robot, it can't respond any faster than that slow sensor, because you're not getting updates of information from it at a faster rate. So that slow sensor is really determining how fast, if you're using it for, say, like navigation, how fast you can make changes or move. Because like David said, if you make them too fast, say you assume that, well, I guess you can't assume, you have to wait for that next reading to come in. But if you're, let's see, how would you say that? Say the amount of gain that you have on, say, steering is too high, then you can get some motions where it's moving forward. It expected a correction, didn't get it, and then says, okay, well, no, actually that doesn't make sense. It's not. It's gonna have to wait until it gets an update. So that's.
Well, I was assuming that if the control loop that's outputting to the motors reads more rapidly than the sample rate you're getting back from the motor, I was assuming that you just get back the last sample.
Yeah.
So 4 samples in a row, you just get what was read 4 samples ago, and then finally it changes, and the next 4 are all the same.
Yeah, I don't. Has anybody in this group done that though? I think we all pretty much, the control loop, or in our control loops for motors, we sample and we determine what the motor out should be, based on that sample. Those two aren't asynchronous.
Yeah.
Yeah. So as
Yeah,
far as I know, no one does that, right?
Has
That's
anyone on the
a
call
very
done
complex
that?
thing.
Like decouple. Has anyone on the call done that? I don't know of anyone.
Yeah. So.
Yeah, that would explain why it's probably really hard to do.
Yep.
Could just be the smallness of our imaginations, though.
No, I guess when I was just kind of thinking about it, to me kind of made it makes sense exactly what you guys are saying, like totally 100%. I guess when I was thinking about it, I thought to myself that, when you're controlling something, like say a person's controlling something or something like that, you have to be able to interface, slower and faster controls on something. You know what I mean? Like you might not always get the same response, I suppose, back. It's not always the same. I don't know. Hard to explain.
I think I kind
Sometimes
of experienced
you
that.
gotta steer a little harder than you normally have to, or sometimes you got to brake a little harder. I don't know. Like
I think kind of what might be an example of that is like some of the joystick controls for the big mower platforms that I have. The throttle is very sensitive, and it just a slight amount of movement will make it almost appear to jerk forward. Like if I just push the stick a little, move it just a little bit, like an 1/8 of an inch, its speed is much faster. It doesn't have there's not much sensitivity on the range there. The steering on the other hand is relatively slow because it's a linear actuator, and it had to have a certain force, so it can only move at a certain speed. So the 2 axes, steering and speed forward and backwards, require very different amounts of change on the stick to get it to be in control. Otherwise it's it surges forward, and and then I back off, and that's where you can get into situations where it's just as far as I'm actually the person closing that loop on speed and direction. And it's, you know, I don't feel the thing actually move. I mean, I'm watching it move, but the watching it move and those first few times that you start to move that stick around, it's kind of like, whoa, that moves quite a bit more than I thought it should move. And, you know, oop.
Well, I have to say that on a real live high dollar transmitter, you can put in curves or define arbitrary mappings for that sort of thing. There's one of these switches up here, switches between linear and exponential mode, because when you fly helicopters, you'd like it to not be so sensitive right around the center, because hovering gets hard if it's real sensitive. But when you get to the extremes, you know, shove it all the way, that's fine, you know. So that could just be a problem in your controller. And you know, $500 or $600 will solve that problem.
Mine was not that expensive.
Oh, but
probably why it likes this feature.
These feel so good. They just baby smooth, you know. I don't know if you can see that, but helicopter pilots fly with what they call pinch grip. That is, you fly with your thumb because you do so many circular movements. You fly with your thumb and your fingers. Airplane pilots just fly with their thumbs, you know, because they don't have that kind of sensitivity. But boy, expensive, really nicely made joysticks are a wonder to behold. These you can go in and adjust the tension, and it's separate on the two axes. For example, there's none on that axis because that's the throttle, and it's a wonderful thing to have. The receivers are cheap. You know that it's a neat technology. You go out and I fly all the airplanes and all the helicopters. I only have one transmitter, and I tell it which airplane I want to fly, and it knows the profile and switches in all the appropriate. But you see, it's got a little display here, and you can actually go in and point by point generate whatever curve you want.
Wow.
And they all do that now. And the new ones, you'll notice this one has no USB connection, but the new ones, you set it all up on your computer and just save it to the transmitter.
See, Ray, you can, with just a little bit of software, you can put your own UI response curves in, right?
Yep.
You can add that exponential response to your.
Yeah. Yep. It's all just a matter of time.
Crappy joystick, but we all know. Our bargain basement dollar, couple dollar joysticks.
Yep.
It's all software.
Yeah, this was a Tanner special. You know.
That's all well and good, but you're putting a nonlinear response into it, and humans are very good at dealing with nonlinear responses. But when you're talking about a PID algorithm, it's a linear algorithm, and a nonlinear response is not going to work well with a linear algorithm.
Well, but I think we're talking about here the transfer curve from your pinch grip or your thumb to the set point into the control loop, right?
Well, yeah.
So that's what we're talking about, not not introducing a nonlinear to the PID loop, because it'll just take it out.
All I'm saying is that David was comparing a human driving a joystick for a helicopter, and that's a totally worlds apart from a PID loop that is a dumb linear algorithm for motor speed control.
I think what I was comparing was the expensive joystick to Ray's cheap joystick.
Oh, okay.
Second.
Just put it
There
out
we
there.
go, guys. Have a good night.
All right, Russ.
Thanks a lot. Ciao.
Yep.
So, okay, David, we have joystick envy, but that's another topic. And I still want to get into helicopters, but there's no time or money. So
you go out and buy a new transmitter every 10 years, whether you need it or not.
Yeah, the only one that I have was from, God, he's one of the older guys in the club. God, I can't think of his name now. Anyway, he seemed to have a lot of them, and he was just giving them away. God, can't think. Oh, Kunkel. Or I'm not certain if that's how you pronounce his last name.
Paul, I have run into that very thing you described, though, when with the two-wheel balancing robot, when I was trying to drive it with the remote, because you in that case, because what you're really doing is you're controlling the tilt angle, and when you get going, you tilt, but once you're moving, you're back upright again. Analogy I've used before is a runner in the blocks. Their center of gravity is way out ahead of their base, and that only works as long as they're accelerating. Once they come up to full speed, they're vertical again. So it's real counterintuitive, I found, to try to drive that two-wheel robot with a joystick, because you're not really controlling the velocity, you're controlling the acceleration. And we talked before about basically once you get the thing going, it'll continue going that way until something else operates on it. So you can set it up where you give the two-wheel balancer a little push, and it'll just glide smoothly across the room until it hits the wall, and then it'll bounce off the wall and slide back in the other direction. When you learn to fly a helicopter, analogy they often give is that you imagine that you're holding a sheet of ice or a piece of glass with a hockey puck on it. And if you want to go in a certain direction, then you have to tilt. But if you leave it tilted, it'll just fall off, right? What you do is you tilt it to get started, but then you have to flatten it back out, and it continues at constant speed. If you want to then stop it, you have to tilt the opposite direction. And if you just do that, it'll just send it back the other way. It won't come to a stop. Coming to a stop is actually requires doing that. Like that. So it's a very different world from the way you think about if you ride a bicycle or push a lawnmower or something like that, because basically it's friction free once it starts moving. That's not totally true. There's other problems with the helicopter. When you're hovering, it takes a certain amount of power. When you tilt the thing to start moving, now you're vectored at an angle, so you don't really have quite enough to maintain your elevation anymore. And so you need to give it a little more power as you start moving. But once you start moving, airflow across the disc itself, which you can think of at that point like an airfoil, will then give you increased lift. So you got to back off on it to keep it from ballooning up. So there's constant, the pilots call it cyclic control, cyclic monitoring. There's constantly messing around with the amount of gain on the rotor. It's not trivial. When you see one of those rescue guys, holding that helicopter steady in the backlash coming off the side of a mountain while he rescues somebody, those guys are great. I mean, they're like violinists. That level of precision is quite remarkable. That's all I got to say about that.
Yeah, I think I'd be like the guys that they used to do it at North Lake Park. I'd have a lot of fuselage parts in the barrel, and the salvage parts on the outside on the picnic table.
I know that barrel well.
Yep.
So speaking of a two-wheel balancing robot, I found this, so y'all might find it interesting. So let me click on something, and hopefully I can find the right window. So there's this thing that looks very cute, and notice it has actually two servos, so it's not just one level balance. So I thought that was interesting.
Very cool. John, can you put that link in the chat?
I will.
Extremely cool.
There's that sort of angle that they show that, and there's seemingly another one out there called that. So I'll run this. I think you'll find it sort of interesting how it springs.
Yeah, very cool.
So you see, we can go even at side angles like that.
That's the kind of thing I do with my dog or my cat.
Well, they mentioned a helicopter going up and down. I'm like, oh, that sort of goes sideways, up and down. So And,
Yeah.
Man,
and it
That's
gets,
I
very
think that
cool.
thing took some lessons from Boston Dynamics or something.
yeah.
Yeah, very cool.
Well, that one's a little fancier, but as I said, they have a simpler version somebody built or in the process of building. So yeah, so you can 3D print the parts there, and then down here is the coal example, and he talks about two parts to it. There's two ways seemingly to do it: angles and conditions or something. And I have no idea if this is French or whatever that is down there, but here's the code for the one part, and it talks about raw and stuff, and velocity. So yeah,
God,
you
it's
might find that
amazing.
interesting. So let me, I think that,
I got you, John.
you got it already?
I put it in there.
Good.
Yep.
Okay. So yeah, I thought that was interesting. And then the one other one, which is not as fancy, but there's another one that you might want to see. Because this one actually describes more about building that, not quite as fancy, but so this one is more along the lines of back. Okay, and we'll start from the beginning. So this one's more simple. It has a spring though in it, so I don't know fully why he put the spring in there. But it's not as fancy in the sense of two motors, so it's more plain with the real spring. But he goes into a very fine detail of building this thing. So this is other one that might be of interest.
Those two big steppers looks like it might have a very low center of gravity.
Yeah. Well, there's Neum 17 motors. You can see he literally goes step by step on so you can see, even to the wiring.
Well, you might want to be careful following his instructions. I could see he injured himself doing it.
Yeah, I noticed that too. But I would think he would have, not have one thumb like that. But,
ouch.
Yes. But, he goes into the finer details, even down to.
Who knows? Maybe the finger was incorporated into the robot or something. Hard to say.
And the thing that I thought was interesting, when you made the comment about balance and all that, and let me see if I can get to, right there. Notice that it has one spot in the center, so basically if he wants to go back, he goes there, then moves it. So, effectively self-corrects itself. You were making the comment about overbalance. As I said, the other one's a little more sophisticated on the build, but this is has a lot more information about billing. So yeah, those are the two I found that was very interesting.
Is this another Indian kid that was, making stuff out of license plates or something?
I don't know exactly where he came from. Let's see.
Broken up.
Let's see.
I've been watching from afar, but those are some cool robots. I foresee that first one getting built on my stream and doing things.
Yeah.
That's really the
first one is very I like the first one.
It's lots of coolness to it, and by the way, I have a couple of those motors sitting around over here from an old robot that I needed something to do with. So
yeah,
Calling to you, Harold.
Actually, I have two too, and it looked very simple and
it looks straightforward, and the print looks good, and all that kind of stuff. And
And then you can use
the circular body might be a little difficult, but well,
for the
Bill one, Harold.
I'm
I
putting
believe at this point only Ron Grant is the only person other than me that has built a balancing robot.
Okay, I mean that's on my bucket list. Believe it or not, it's a balancing robot. It's on my bucket list, and then
That would give us 3.
Oh
So
yeah,
I would use the
three is
first
a good
one
price.
for
I love
print.
that price.
I would use the first one for the print, and then use the second one for additional information design-wise, because the second one has less colon information.
I mean, I'm assuming with the ultrasonics on as for eyes, it's just not. It's just not for cool lookingness, but at the very least, I could set that loose in the office and let it run around and not bump into things. Hopefully, and get. One of the things I try to do at the office is bring in fun little toys like this or fun, interesting stuff to hopefully do some guerrilla marketing to say, we need to find projects where we're actually building these things, so now I can get paid to build a thing that's on to say we have this expertise or something. But anyway, I'll be quiet.
Well, I'll also say, Harold, that in my experience, and I built a couple of balancing robots, is the real challenge is tuning the algorithm, which is that you've got it's like a PID controller, but you have 4 constants and they all interact with each other. And so if they have a physical design with the motors and the power and the weight distribution, they've done that part for you. They give you those numbers.
That's how I got my rover built. It's because somebody's already done that part, and it's a problem I don't want to solve, but I do want to solve the other problems about making things go in directions and that kind of stuff. Yeah, exactly.
If you look at the people who dig into this real deeply, they'll all tell you that basically you have to build a software model of the plant, and then you can automate the process of coming up with the proper constants. But that in and of itself, I mean, that just makes it a much, much bigger problem.
One interesting feature of a couple of those robots was it looked like they could change their height, could actually stand up further or squat.
And also lean side to side, which is a big deal.
Yeah.
That's a real big deal.
Bruton has some of that on his much more powerful robots, by the way. On his side, when he does these things with these 2 wheels, looks like a Sonic looking thing, and it's got some speed and it's got lots of lean and turn and all that kind of stuff in there. And he does some of those things. I'm like, well, I can't afford that because just to try something. But this thing, oh yeah, heck, I can buy parts for it at the local, at like Hobby Town, because they've got those kind of little motors in there and that kind of stuff. And if I don't have those motors already laying around.
Plus, they were going upstairs. The balancing robot on its own will go downstairs because it just has to keep balancing as it drops from step to step. But going up the stairs is hard. You can't just lean forward and increase the torque. And they were doing little jumps to get up to the next step, which is very cool.
Yeah, very cool. I gotta go put that in my list of things.
And another impressive part, kudos to John. Look closely at the date for that first one. It was posted today.
John, you're an animal, man.
Score, man. That's
awesome.
That's amazing.
Harmonic convergence, huh? John just happened to be looking at Thingiverse at the moment it was released, right?
Yeah, almost.
Or that's your new job as Thingiverse moderator.
I just thought it was cute. They don't publish good things like that every day, though, unfortunately. But
all right, how are we doing? Are there any other topics going? I see some people sinking back further into their chairs. I'm there with you.
Well, actually,
yeah.
Actually, hauled out my license list.
The reader?
The Opencv sample that I was working on and was trying to improve on license plate detection, and I realized, hey, that program is basically looking for parallelograms in the image, the license plate. Well, the same thing applies to a chain link fence. So I actually just now spent some time downloading some pictures of some chain link fences.
I need a
ran
video, but I hate being on
and ran it
camera.
against the program,
What are
and
my
I
options?
realized, you know what, is considering all the variables in a real environment, just using Opencv by itself would be really, really challenging. I think Pat's going to have to use a neural net if he's going to do that.
Oh.
Because when I looked at the results, it was doing things like, there would be gaps, like if the sun was shining at a certain angle, you wouldn't get a nice diamond shape because it would be interrupted by the shadow of part of the link in the chain link fence, and so you wouldn't get. And when you're close up, the links in the fence are not actually very straight; they're very curved.
Oh, that's true. Yeah, that's like a spiral.
Yeah. So he's interested in going that route. I'd be interested to see if he goes the neural net route. I'd like to piggyback on that and see how he does it.
That's what I was saying.
You
He
also
should
have
do
to be
the.
careful. Some of those
Oh.
things that look hard at first glance may turn out to be trivial when you actually, and vice versa. So, when we first started the can contest, the understanding was that the only way you could recognize a can would be with a camera. And what I determined real quickly was that in the contest course, there's nothing else that has the same sonar profile as a can. And so all I had to do was find the edges of the can and I could zoom in on them. I didn't even have to know it was a can. There was one failure mode, which was the contest course we used at the time. I believe a superior course to the one we use now was the shape of a T, purposely so that it had both inside corners and outside corners to challenge wall followers. And those inside corners look like a can. However, since I was using odometry to keep track of where I was, I could eliminate those sonar reflections just because they're not in the right place. I rejected everything that was within 6 inches of the wall as not being a can, which meant that was another failure mode if the judges put the can 6 inches close to the wall. However, without me saying anything, somebody changed the rules to say cans have to be at least a foot away from the wall. And so I was set.
Yeah. Well, if you got a few minutes, I actually have the program running.
Oh,
Go ahead and
get this.
share.
A little real-time Opencv.
Wait a minute. Nope, I clicked the wrong icon. Present now. Here we go. This screen, share. All right, well, let me find. Oh. All right, can you see my Raspberry Pi desktop?
Yep.
Yep.
All right, so here's one image. There's the original image of a chain link fence that I downloaded. And if I take that original image and convert it to grayscale, and then do a little Gaussian blurring on it to improve the edge detection I'm about to do, and now do edge detection, this is what I get. This is actually one of the more ideal cases. Now, the next step will go through the image and essentially look for parallelograms. And they'll be identified. The ones in blue are basically 4-point contours that it found. And you can see it found quite a few. So if you were looking for a chain link fence and you said, let me just count the number of parallelograms in this image of approximately the same size, you could probably reasonably guess that's a chain link fence.
Yep.
But that's kind of the ideal case. I've got some other cases here that don't work out very well.
It's the white cow in the snowstorm. It's not going to work.
So there's different lighting, different angle, grayscale,
Blurring.
blur the image. There's the edge detection. and this one actually did reasonably well. It found quite a few parallelograms, but the cases where it doesn't is where there's the links overlap and it kind of breaks the contour. So let's look at another one.
Can you widen the parameters for a parallelogram? Can you say, you know,
Well,
fat
I
line
can
or
also
fat
change the program. Instead of looking for parallelogram, just look for line segments and try to find. Here's a grayscale. Try to find. Now this is one of the hard ones because you look at the shadows. The shadows break the lines up quite a bit. So there's the edge detection. So it has quite a bit more trouble finding any parallelogram. But like I said, if you broke this into finding line segments and say, well, I found a large number of line segments that are approximately parallel, that would probably do for detecting a chain link fence.
Yep.
Wow.
And then
Cool.
finally, here's the worst case. So,
Oh yeah.
you know, the curvature of the links here really messes things up when you're at an angle. So,
And you're also very close to it, right?
yes. But
See,
anytime you're at an angle to a chain link fence now, there's almost nothing straight lines.
But that close, even the weak sonar might actually work. So, you know, maybe this job has to be split up among more than one sensor.
On the positive side, though, it's not keying off of things like in the background image, grass or
yeah,
you know.
Yeah,
so that's pretty good.
As long as you do an appropriate amount of blurring, you can limit the interference from background.
Yep.
And on the other positive side, you knocked it out in like 5 minutes. So.
Yeah, very impressive, John. Very
impressive, John.
Well, I already had the program. The program was designed to try to detect license plates, and I realized, well, chain link fence has a bunch of parallelograms in it too, so it probably works the same. So I just found 4 images and downloaded it. And,
very cool.
So license plates look more like parallelograms, not rectangles?
Well, here, let me.
Well, you're not seeing them necessarily
I
square
can see
on.
that. If it's going away at an angle, you've got it skewed at least a couple of ways to get into the parallelogram version of that.
Right.
Yeah,
So here,
that's
this will show you what I was trying to do with license plates. All right. So there's an image from my street camera.
See,
Look at all the parallelograms in that image.
Yeah. And then you convert to grayscale, blur it, do the edge detection, and the one in green, when it draws an outline in green, it says, I think that's a license plate. The blue ones basically said, no, those don't fit the description. Because what it does is it tries to find an object with a certain ratio of opposite sides to each other, opposite sides that are approximately the same length, and then approximately parallel. So that was a successful case. But that's what it's trying to do. And I think I have a.
Looks like it
Well,
works.
I guess a rectangle is a parallelogram. You know?
Yes.
Yeah.
Rectangle is a parallelogram,
Yeah.
a special case.
Yep.
Let's try this on one. I think the next one failed. Yeah, the next one failed, and I'll show you why. There's the grayscale. There's the blur. There's the edge detection. And you can see right away whether there's going to be a problem. It can't distinguish between the bottom of the plate and the bumper. There was no, in the image, there was no clear division. There's no sudden, sudden gradient from the bumper to the license plate. So it couldn't find the plate.
Well, we obviously need a standard for license plate mounting.
Yeah. But that just goes to show you, real world conditions. It'll defeat you every time.
I also noticed, John, that for your 2 truck images, oh my goodness, did it seem to nail them in exactly the same part of the image?
Well, I've got other examples here where it was off of that.
What do you mean, Carl?
Well, he had the trucks pretty well centered from left to right.
Oh.
Well, I'll give you an example where that wasn't the case. Those just happened to be the images I was demoing.
Oh, just happened to be gold plating the story. Okay.
Well, you didn't have to tell us that.
cherry picking.
That's a nighttime image.
And it's awesome. It was perfectly centered left to right. Look at you go.
That one didn't work. That was nighttime. Let me find the right one here. I think it's this one. There.
That's still pretty good.
That one's considerably off center.
That's pretty good.
You got a good border all the way around it.
For a moment, I thought everybody drives a pickup truck down there.
You wouldn't be far from wrong.
But why didn't it find it?
No, it found it, but it found 2. For some reason, it found 2 parallelograms almost in the same place, and drew the green. You could barely see the green.
Oh yeah.
Yeah, because it drew the blue box over it.
Yeah.
So it found 2 of them, but the best one is in green.
So it's saying this is a license plate, but maybe not.
No,
It isn't at the same time.
It just took the best case. The best case.
Schrodinger's license plate.
Well, there's a plate and a non-plate in the same location.
Very zen.
Exactly. Yeah. So anyway, but I had limited success with this program so far. I'm trying to basically produce something better than the open ALPR algorithm that you can. It does the license plate detection and OCR. Love to get into doing to try to replace that with the neural net solution.
I stopped the little truck that drives around SMU putting tickets on people's cars and talked to them and asked them how much interaction it took from them. I said, do you have to point the camera at the license plate? They said, no. It figures out where the license plate is by itself. They said their only interaction, and this is telling, is that sometimes when the system fails, they have to interact with it. But basically, they just drive along in a straight line, and their little camera identifies the car and the license plate, looks up in the database if you're registered, and issues a ticket if you're not. Their main complaint was that it wasn't air conditioned.
One of the things I found out when researching this was that the models they have for license plate detection, the models that they've trained, are very jealously guarded.
Interesting.
Nobody shares those for free.
Well, I have to point out, this is just a random observation, but that I've noticed over the years. Now that I have an Oak Light, I'm guilty myself, which is that we spend all this time and money and energy to come up with these real high resolution color cameras. And then the processing, the first thing we do is you get rid of all the color and make it black and white and reduce the resolution to 32 by 64.
TMI, too much information.
So I'm changing the subject if we're kind of like wound up, because that was a very cool demo, John. Thank you for that. I'd like to seek the wisdom of those who've played with BNO 55s on some data I just took. So I rotated I took two runs of rotating the sensor in 90-degree increments all the way around to 360 and then back in the other direction. So 2 runs of that. Looking at the delta between them, which should in theory be 1.57, that being pi upon 2, And then I took the ratio between the delta and 1.57, which would give me a percentage divided by 100, percentage divided by 100 of difference from what was expected. And I observe in this run, many of the readings are within 2%. There's a couple at 4%. And so this is really a measure of linearity measured at 90-degree increments. This one was not so good. It had like an 8% to 6%. And then, the rest were in the sort of like 2% range.
Yeah. Are those just two runs with the same physical configuration?
Yes. Yes.
Okay.
And winding it one way and then the other. And the reason I did that was because I was playing with the accelerometer on the B&O55 and I found it had stiction. So when I moved it one way, it stopped with an offset positive, for example. Then I moved it the other way and it stopped with a negative offset. So I was like, I wonder how linear this this heading sensor is. And I just wonder if any of you guys who've used B&O55s have any experience with the linearity of the compass heading.
Paul, I think Chris has already signed off, but I believe he encountered that exact problem and ended up to kind of have to do a kludge to get around it.
Oh, really?
Am I remembering that correctly? Does anybody else?
Yeah, it seemed like he had a fixed offset that he, I guess, corrected somehow. I don't remember how.
Okay, maybe I'll bring it up next week and see if I.
Yeah.
Well, Ted uses one of those, and he showed us a demo not too long ago where he was rotating in place and just nailing it every time around, over and over again. So
he's nailing it within what kind of percentage?
Well, nailing it from me looking at his video.
So yeah. So I've used that on the Mechanum wheel one that I did, the hovercraft simulator, and what I showed was that if the thing was sitting stable on a table, it would report the same, and so it's not moving. It would report the same heading to within 0.1 degrees. It wouldn't change over a day's time. But if I would put that on a turntable, not even using the Mechanum wheels, which have vibration, right? But if I put it on a pretty smooth turntable, and if I just moved it a few degrees and moved it back to as close as I could get it, it was off by a degree or two. And
well, that doesn't seem right.
No, but we had this discussion. The best theory that I had at the time was that, so I use the sensor and I tend to use it in full-on fusion mode, or one of those 2 of its 3 sensor fusion modes. And the theory that I promoted was that it's using to take care of, to kind of zero out the gyro bias, which is going to creep in. The theory that I had was that it's going to use the accelerometers to tell if it's moving. So if there's no input from the accelerometers, it must be standing still. If it's standing still, therefore the gyros should be reporting 0 velocity. So in other words, if it's not moving, it can self-calibrate out gyro virus. But as soon as you start moving it, then that algorithm that attempts to take out 0 movement probably introduces errors. And that's
from
the
my
theory.
reading. From my reading, I believe that, so this is a fusion mode, but my reading of the data sheet leads me to believe that it uses the magnetometer and the gyro together. So if it's not moving, then the magnetometer is stationary, and therefore it knows that the gyro is, it would take out the drift in the gyro.
Sure.
I mean, similar kind of thing what you just said. I'm just saying replace accelerometer with
magnetometer, or both of them, right? Because it could use both.
Yeah,
for different.
But I think the point that brings up is the result is then the linearity is then the same as the linearity of the magnetometer, I think.
Or it could be limited by.
So anyway,
well, no, most people in this ensemble, I believe, running their robots indoors don't use the magnetometer. You know, one way to think about that is that when you're sitting still, all other things being equal, the magnetometer should show that you're not rotating. But once you begin rotating, there are iron rebar in the floor and the refrigerator and all kinds of things nearby that can actually distort the linearity of that magnetometer. So I'm not sure in the case that that Carl was describing whether he had the magnetometer engaged or not.
I can't remember because I've tried both modes. I've tried it fusion with magnetometer and I've tried it fusion without magnetometer, and I don't remember the results, but I do remember that I couldn't find a combination that would let me do that simple test on a fairly smooth turntable, turn it a little bit and then return it. I couldn't find something to get it with worse than a couple degrees or better than a couple degrees.
Well, the way those extended Kalman filters are set up, basically all your gyroscopes are going to drift because you're actually integrating and integration drifts.
Right.
But the way you correct for that is you need something that gives you a correct long-term average. Short-term average is not correct. The advantage of the gyroscopes is that their short-term position is very correct, but their long-term position, because you're trying to integrate that to get a heading, drifts around. So, well, like for the example in the bouncing robot, you use the accelerometers, which are measuring the acceleration of gravity. And now the robot's actually wiggling back and forth, so that number's moving around. But long-term, that number is very accurate. Where down is very accurate. So you use that long-term to correct the long-term drift of the gyroscope, but you don't use that long-term for the moment-by-moment movement of the bot. And then for a magnetometer, for an outdoor robot, the magnetometer does the same thing for the z-axis gyros. That is, they're drifting around, but the magnetometer, it's moving around on the short term, but over a long haul, its average is very accurate. Its understanding of where north is very accurate. So you can use the long term to correct the short term, and you know that all ends up this great big matrix, you know, that no mortals can understand. And it's probably best that's the sort of thing that I think if somebody's actually figured out how to do that, and I know there are people who eat and sleep, you know, Kalman filters, that I will just pay them for their solution and get back to building robots.
So Carl, these when you look at these percentages, that's percent is about a degree. So I am looking at the sort of 2 to 4 degree range of accuracy here. And
to my memory, that's about what at least from my experiment of a lazy Susan, turning it, 90 degrees or so and moving it back.
Yeah.
But the crazy thing was, I mean, I'm telling you, letting it sit all day and it read exactly the same angle within a tenth. I mean, it was a tenth of a degree angle, didn't change all day, but you moved it and it's
I've
off.
observed that. Yeah. Well, thanks for your input, guys.
Yeah. Good luck. Let us know when you solve it.
Yeah. Tell us how you did it.
Solve it. Is it bad enough that it needs to be fixed? That's the question.
Well, there's an answer. I love it.
I think for me, if my lawn mowing robot followed in its own wheel tracks, that was close enough. So I didn't get down to measure, okay, if it turned just slightly or turned 90 degrees, was it, within a few degrees or not? But
well, what Carl indicated with his test was that error corrected itself when you went in the other direction, right? That is, it was off by 1 degree going left. It was off by -1 degree going right.
Was it symmetric? I don't remember.
So in that case, if you're just driving around randomly, that should average out.
Let's go with that until proven otherwise. Yeah. So the out and back has to be out and back. You can't just be out.
That's why we have a Robo Columbus instead of a Robo Magellan. You may remember that Magellan died halfway through his trip.
Don't upset the natives, I think, is the key.
That's awesome.
Columbus made it back home. Making it back home is the whole point of navigation.
So what? Now we're going to come up with Robo Lewis and Clark?
Do they eat the other robots?
Well, that would
There's
be
a
Robo.
contest.
What was the infamous
Donner Party?
Cross, huh?
Donner.
The Donner Party.
Oh, yeah, Robo Donner.
Okay, well, I think as Ray pointed out, in the interests of comity, we should call it Robo Sacagawea. Wasn't she the guide that went along with Lewis and Clark?
Mm-hmm. Yeah, I think she actually had one of their children.
So she was more than a guide.
Obviously so.
Guide plus. Yeah.
Guide with benefits.
There you go.
Oh my goodness.
Robo Sacagawea with benefits.
Oh my goodness. This is really devolving.
Okay.
Yes.
This is our cue, guys.
Good night,
Bunch of old
guys.
farts. See you all
We'll
next
see ya.
week. Take care.
Yeah.